In this video, we are going to explore the economic theory of consumer choice, which will enable us to understand where demand comes from. Let's consider a hypothetical consumer we'll call Anne. Anne cares only about tablespoons of peanut butter and cups of milk. In fact, she's sitting down to a meal where she is going to put away 20 tablespoons of peanut butter and wash that down with just 1 cup of milk. Now put yourself in Anne's shoes. If you're going to eat 20 tablespoons of peanut butter with just 1 cup of milk, would you be willing to give up some of your tablespoons of peanut butter in exchange for milk? If so, how much? And since she has so much peanut butter and so little milk, she's willing to give up 5 tablespoons of peanut butter in exchange for just 1 additional cup of milk. Again, this is because she has so much peanut butter. She's willing to give up quite a bit of it in exchange for just 1 cup of milk. Now, with 15 tablespoons of peanut butter and just 2 cups of milk, is she willing to give up yet more peanut butter in exchange for milk? Sure, she doesn't have as much peanut butter as she did, so she's not quite as willing to give up peanut butter for a cup of milk as she was before, but she's still quite willing. She's willing to give up 3 cups of peanut butter in exchange for just 1 more cup of milk. Points A, B, and C all give Anne the same amount of satisfaction. The economic term for satisfaction is utility. So points A, B, and C give Anne identical amounts of utility. She's indifferent between those points. She's also indifferent to point D. In other words, point D gives her the same amount of satisfaction as points A, B, and C. Here, she doesn't have as much peanut butter, but she has quite a bit more milk. She has 4 tablespoons of peanut butter and 10 cups of milk. Is she willing to give up peanut butter in exchange for more milk? Yep, she is, but not as willing. She's now only willing to give up 1 tablespoon of peanut butter for 3 cups of milk. She needs quite a bit of milk now to compensate her for loss of peanut butter because she doesn't have much peanut butter now. If we draw a curve through points A, B, C, D, and E, we get an indifference curve. An indifference curve shows consumption bundles that give a consumer the same level of utility. So she's indifferent between any of those points on indifference curve number 1. Let's look at bundles F and G. These bundles give her a higher level of utility or more satisfaction. That's because they're on a higher indifference curve. As we move out away from the origin to combinations that give us more milk and peanut butter, that moves us to a higher indifference curve. So bundle F or bundle G will give her more utility than bundles A, B, C, D, or E. But yet, how does bundle F and G compare to each other? Bundle F and bundle G give Anne the same amount of utility. Or in other words, Anne is indifferent to bundles F and G. How does H compare to F and G? Well, bundle H gives Anne even more utility. It's on a higher indifference curve. The marginal rate of substitution, or MRS, is the rate at which a consumer is willing to trade one good for another. This enables us to look a little more deeply into this idea of how Anne's willingness to exchange peanut butter for milk changes. Let's go back to bundle A. At bundle A, Anne had 20 tablespoons of peanut butter and just 1 cup of milk. At bundle B, she had 15 tablespoons of peanut butter and 2 cups of milk. So she gave up 5 tablespoons of peanut butter in exchange for 1 cup of milk. The mathematical definition of the marginal rate substitution is the absolute value of the change in the good on the y-axis over the change in the good on the x-axis. Or in other words, it's the absolute value of the slope of the indifference curve. And so, what is the marginal rate of substitution between A and B? Between A and B, again, Anne was willing to give up 5 tablespoons of peanut butter, which is on the y-axis, in exchange for 1 cup of milk, which was on the x-axis. Or in other words, she's willing to give up 5 tablespoons of peanut butter per cup of milk. Or in other words, the marginal rate of substitution is 5. That gives us an actual quantity, an actual number that describes her willingness to give up peanut butter in exchange for milk. Let's calculate the marginal rate of substitution as we move from B to C. Here, she's willing to give up 3 tablespoons of peanut butter in exchange for 1 cup of milk. Or in other words, she's willing to give up 3 tablespoons of peanut butter per cup of milk. Now let's look at the marginal rate of substitution from point D to point E. Here she was only willing to give up 1 tablespoon of peanut butter in exchange for 3 cups of milk, or in other words 1/3, 0.33 tablespoons of peanut butter per cup of milk. So that number, that marginal rate of substitution again, is describing her willingness to give up peanut butter in exchange for milk. And you see that it goes down. As she gets more and more milk and less peanut butter, she becomes less and less willing to give up peanut butter in exchange for milk. So far in our analysis, we haven't had any income or prices in it. But yeah, if we really want to figure out what combination of peanut butter and milk is going to make Anne as well off as possible, we need to understand something about what she can afford. What is her income and what are her prices? And so we want to introduce income and prices into our analysis now. Let's suppose that Anne has an income of $4 and the price of peanut butter is 20 cents per tablespoon. If Anne spent all $4 on peanut butter, how much could she buy? Well, to find this out, we'll take the income of $4 and divide it by 20 cents. Or in other words, the price of peanut butter. So $4 over 20 cents, that gives us 20. So we'll mark on the peanut butter axis the point of 20. That, on that y-axis, on the peanut butter axis, at the point of 20, that gives us how much peanut butter she would be able to buy if she spent all of her income just on peanut butter. Now let's suppose that the price of milk is 25 cents per cup. If Anne spent all $4 on milk, how much could she buy? Again, we'll take $4 income and divide it by the price of milk, 25 cents, and we get 16. So if Anne spent all $4 on milk, she would be able to buy 16 cups of milk. If we connect these 2 points with a straight line, this gives us a line that we call the budget constraint. This budget constraint shows us all combinations of peanut butter and milk that Anne can afford. For instance, point A, where she's buying 10 tablespoons of peanut butter and 8 cups of milk, is a combination or bundle of peanut butter and milk that Anne can afford. How about bundle B? She can afford that bundle too. But yet at bundle B, she's not spending all of her income. At bundle A, she was. So any point on the line, she's spending all $4 of income. Any point within the line, she can afford it, but she's not spending all of her income. Let's look at bundle C. Bundle C isn't affordable. That's because it's outside of the line. So any bundle or combination of peanut butter and milk outside the line, above the line, is not affordable. Anything on the line is, she's spending all of her income. Anything within the line is affordable, but not spending all of her income. Let's suppose that Anne has $5 of income now, and the prices haven't changed. How much? If Anne spent all $5 on peanut butter, how much could she buy? Again, we'll take $5 income and divide it by the price of peanut butter, 20 cents, and we get 25. She could buy 25 tablespoons of peanut butter. How about if she spent all of her income on milk? Again, we'll take $5 income, divide it by 25 cents per cup price, and we get 20. So if we connect these 2 points, we get a new budget constraint, which shows that she can now afford more. In fact, she could afford bundle C. Now, we want to combine the indifference curves and the budget constraint to determine what combination of peanut butter and milk will maximize Anne's utility. Look at point A. Does it look like Anne is maximizing her utility at point A? Or in other words, are there combinations of peanut butter and milk that would give her more utility than she gets at A, but yet still be affordable? Certainly. Let's look at point B. Is that making her any better off than point A? You can see now at point B, she's spending all of her income. But yet, is she any better off? No, she's not. Because at point A and point B, she's indifferent between those 2 points. They're on the same indifference curve. A and B give her the same amount of utility. So at point A, she wasn't spending all of her income. At point B, she is, but she's still not better off. How about point C? Point C, well, she's once again spending all of her income, but she's on the same indifference curve. She's not any better off at bundle C either. What is she going to have to do to get to a higher level of utility? Is it possible? Well, sure it is. Consider point D. Point D, she's spending all of her income. And she's on a higher indifference curve. She's on indifference curve number 2 there. And so she prefers D to points A, B, and C. But yet, is she maximizing her utility yet? What's it going to look like when Anne is maximizing her utility? We want to keep moving to higher and higher indifference curves until we can't move out any further without moving off from the budget line. So we'll push that out as far as we can. There we've slid the indifference curve out as far as we possibly can without moving off the budget constraint. That enables Anne to consume at bundle E, which is 7.5 tablespoons of peanut butter and 10 cups of milk. You can see there that the indifference curve 3, is tangent to the budget constraint. That means the indifference curve and the budget constraint at point E have the same slope. And so, again, what have we done? We found the point, or the combination, the bundle of peanut butter and milk that makes Anne as well off as possible, that maximizes her utility. Point E is that point. If we move to any higher indifference curve, well, then point E, if we try to move to some indifference curve 4, to a higher indifference curve, well, we won't be able to afford it anymore. We'll obviously be off the budget constraint. Let's suppose that Anne now has $5 income, but still faces the same prices. Price of peanut butter is still 20 cents a teaspoon or tablespoon, and milk is still 25 cents a cup. But now she has $5 income. You can see that new budget constraint reflects that higher income. Can she get to a higher level of utility than she can at point E? Yeah, you can see now that it's possible to move to yet a higher indifference curve. Like point X, where she has 12.5 tablespoons of peanut butter and 10 cups of milk. You can see once again that the indifference curve has the same slope as the budget constraint at point X, where she is maximizing her utility. Now let's suppose that income is $4. The price of peanut butter is still 20 cents. But now let's suppose that the price of milk has gone down to just 16 cents per cup. How would her budget constraint change? Well, at a price of 16 cents, she can now afford 25 cups of milk if she spends all her income on just milk. If she spends all of her income on peanut butter, well, since the price of peanut butter hasn't changed, she can still afford just the same amount of peanut butter. So you can see that when the price of milk goes down, the budget constraint pivots out in such a way that she can buy more milk. But yet, if she spends all of her income on peanut butter, well, she can still just buy 20 cups of peanut butter. Now look at point E. Point E, when her income, or excuse me, when the price of milk was just 25 cents a cup, point E was the utility maximizing point. Now, can she get to a higher level of utility? Yeah, she can. If we move out to indifference curve number 2, you can see that she's at a higher level of utility now. She can now consume at point F, which is 10.4 tablespoons of peanut butter and 12 cups of milk. This table gives us a summary of what happened. Before, when the price of milk was 25 cents a cup, she was able to afford 9 cups of milk. Now that the price of milk has gone down to 16 cents a cup, she can now afford 12 cups of milk. What does this table give us? This table is actually giving us a demand schedule. What we want to do now is graph this demand schedule. It's the demand schedule for when income is $4 and the price of peanut butter is constant at 20 cents a tablespoon, but yet we're varying the price of milk. Again, when the price of milk was 25 cents a cup, she was able to afford 9 cups of milk, and when the price of milk was 16 cents a cup of milk, she was able to afford 12 cups of milk. If we connect these dots, we get a demand curve. And so we've derived the Ann's demand for milk. It shows that as the price of milk goes down, quantity demanded of milk goes up.